We are live. We are live. We are live. We are live, my dear friends. I hope you are all doing fine. You are all doing fine. So first, do tell me the quality of the broadcast. If I'm audible enough, and if you are seeing the video good and fine, then you can rate it 10. 10 means it's excellent. 10 means it's excellence, and 1 if I'm not audible, and if the visual that you are seeing is not clear. 1 for the worst broadcast and 10 for the best. So you can rate it between 1 to 10. 1 2 3 4 5 6 7 8 9 10. So you can rate it between 1 to 10. Now do tell me how's the preparation of the exam is going on. Okay, Rupesh, very good. 10, I think 10 is fine. So first, do tell me the quality, the preparation, how's the preparation of the exam is going on. 1, badish. 2 is okayish. Okay, 2 is okay. And 3 is excellent. 3 is excellent. 1 2 3. 1 2 3. 1 for the bad, 2 for the okay, and 3, very good, excellent. No caution will be spared by me. That is for the 3. And for the 2, I understand all the things. 2 is for the I understand all the things. But sir, how do I apply those things in the question? And 1 is for the them that who are weak in the basics and need some guidance. So 1 2 3. So Rupesh is on 2 and our cartoon friend is on 1. Make sure buddy you change your name. I know it's kind of funny. I like funny. So 1 2 3. 1 2 3 1 2 3 1 2 3. Today we will do the wave optics introduction. We will start from the ground level. We will start Yashita 1, okay? So if you don't know what is wave optics, how it is important and how to do it, so this class is actually for you. So today we are going to start from the very basics. If you haven't done anything in the wave optics, after seeing this class, you will enter in the territory of the wave optics. Okay, my dear friends. So first, let me tell you about myself. Who am I? This is me, Raghav Sharma, has an experience of 3+ of teaching, MSc Physics, silver medalist, not gold medalist. I just one guy has 5 marks more than me, so he was gold medalist. And BSc Physics honors from the DU, BEd from MDU, research work done in JNU, Jawaharlal University, and article published in the JACS journal. Eagerly waiting, sir. We are starting, buddy. We are starting. Just wait a minute. We are starting. So after this, our goal for today, what we are going to achieve. So first we are going to talk about what? Introduction. This is your and our goal. We will do introduction of what? Of the wave optics. Then we will do Newton corpuscular theory. A giant. Newton was a giant in his field. Then we will do Huygens wave theory, and we will also do some caution time. Okay. Today class will be mainly about theory because it is an introduction. Tomorrow our class will be focused more on the numericals, in which we'll do interference. So this is our goal for today. this is what we are going to do. So first for the all, if you have not joined our Telegram channel, if you have not joined our Telegram channel, alt neat, okay, we provide you some PDF materials. Okay, we are doing wave optics, so when we do all the complete things of some specific topics, we will provide the material in our alternate channel, and also to provide some other things also, and give you the announcements of free classes, the classes we are providing. And we also do what? Discounts and giveaways. Yes, we also do giveaways. You just have to follow us on what? On the Telegram channel alt neat. So the moment that you are all waiting for, that moment has come. So let's start the Newton's corpuscular theory. That theory was given in when? 1675. You all know that the right theory for the light is de Broglie's dual nature that he has given. But my dear friend, let's start from the past. Till 18th century, yes, till 18th century, this theory remains prominent. This theory remained prominent for almost 200 years, for the 2 centuries. Okay, this is what all was following in the past, almost for the 2 centuries, from 16th, from 16 to 18 something. So this theory was important. So what Newton said in his theory, Newton is, Newton's name has a very specific weight in it. So what he said, and he proved some things, and some things haven't proved from this theory. So he said that every light source, it emits what? It emits, okay, let's make a source. Let's say this is source S, and it is emitting tiny particles, corpuscles. Okay, it is emitting corpuscles. They are massless. They are elastic. They are rigid, and they can be of different sizes and different shapes. Like it can be triangular, it can be square, it can be circular. So what it was saying, and it can be of irregular shape, it can be of any shape. So the light source emits what? Corpuscles. Okay, it emits, you can say, it is emitting massless particles, not photon. It is emitting what? It is emitting massless particles, which can be of different size and shapes. SHAPES. So it is emitting massless particles, elastic, rigid, different size and shapes. This is what Newton said in 1675 in his theory. And what he said? He said that these particles move in a straight line. Like this, straight line, and they will have different speed in different mediums. What? Different speed in different medium. Different medium. He said in denser medium, according to Newton's corpuscular theory, the speed in denser medium will be greater than velocity in rarer medium. Are you getting? We know that this is wrong. This is wrong. Velocity is actually greater in rarer medium, but according to Newton, he said that velocity in denser medium is greater than velocity in rarer medium. Okay, so we can say that velocity in water will be greater than velocity in air. This is what Newton's corpus theory said. Corpus theory said. Third thing he said that thus we know Vibgyor, violet, indigo, blue, green, yellow, orange, red. This is our light spectrum. This is our light spectrum. This is our light spectrum. Are we clear? Are we clear till that? If you have any doubt, you can just write in the chat box and I will answer your all the question. So what Newton said? If it is triangle, okay, if it is this shape, it will give violet color, this shape and size, and if it's this shape and size, it will give blue color. I am just giving you the example. It's meaning that blue color will be given by some specific corpuscular, and violet will be given by some specific what? Particles. Okay, different shape and sizes. So if you see here, if it's this size, it will give green, this size will give blue, this size will give blue, and this size will give red. Different size of corpuscles and different size of different light. Okay, are we clear? Are we clear till that? Are we clear? If you have any doubt, you can ask me. So this theory cleared many things. Okay, this theory proved many things. What it proved? It proved rectilinear propagation of light. It proved reflection. It proved refraction. What it hasn't proved? Dispersion, interference, diffraction, polarization, double refraction, Doppler effects, and photoelectric effect. That thing doesn't prove that all much things. So it is proved what? Rectilinear propagation of light. What this thing says? It says light travels in a straight line. Light travels in a straight line. It proved these things. Light travels in a straight line. So it proved Newton's corpuscular theory proved the rectilinear propagation of light. This is particles, and if it is affected by anything, it will move in its direction. Okay, Newton's law of inertia, if it is moving, it will keep on moving unless it is acted by an external force. So he said it is what? It is a massless particle. It is a massless particle. If this particle, if it is not affected by what? External force. If it is not affected by external force, it will keep on moving in a straight line. It will keep on moving in a straight line, and this theory, okay, he say, or Newton said that, so it will be okay. So all done, sir, all done. We get it. So it proved rectilinear propagation of light. Another thing, reflection of light. What Newton said? Newton said it is elastic. It has elastic nature. So what it will do? It will do the conservation of momentum, and conservation of energy. If it is purely elastic in nature, it will follow two principles: conservation of momentum and conservation of energy. Conservation of momentum and conservation of energy. So if it will come like this, after reflection it will go like this, momentum equal. So if this is angle I, this will be angle R, and if we apply those two laws, we will get angle I equal to angle R. Elastic collision is happening. Elastic collision happening. So angle I equal to angle R. Coming incident momentum equal to what? Initial moment equal to final momentum. Only direction is okay. So if we apply those two things, we will get angle I equal to angle R, and we will get this law, angle I equal to angle R. So this thing also get proved. Reflection of light. Third thing, he explained reflection of light. What he proved? He proved reflection of light. And for this, he said in denser medium, there are lot of particles. There are lot of particles like this. It is filled with the particles. It is filled with the particles. Imagine something is coming like this, and this is particles, and they will all apply what? They will all apply force. They will all apply force. Okay, they will all apply force, like come here, come here, come here. There are pass to out. So they all will apply force. So this is also applying, this is also applying, this is also applying, also. So they all will apply some force, and there will be a resultant force in this direction. There will be resultant force in this direction. If we do the mathematics, there will be resultant force in downward direction. So initially it has to go like this. It should have been gone like this, okay, but there is resultant force, a force due to this attractive force, attractive due to the particles like this in downward direction. So there are two forces. Initially it has to go like this, a force due to particles in downward direction. So a resultant of these two forces will come, and a force and direction will change like this. Incident corresponding after reflection, it has banded. It is banded, and it is give rise to what? It explained the refraction of light. Refraction of light. This is why Newton said that velocity of the particle in denser medium will be greater than velocity into the rarer medium. Into the rare medium. Incoming corresponding, say this is rare medium. So here velocity will be less, and here in denser medium velocity will be high. Velocity will be high. Any doubt? Any doubt, my dear students? Rupesh, Shruti, Yashita, any doubts? If you have any doubts, you can just ask me. You can just ask me. I am here for your doubts. If you have any, you can just ask me. You can just ask me. After this, it failed to explain interference. It hasn't proved interference. It hasn't proved diffraction. It haven't proved polarization. And we all know that velocity in denser medium is less than velocity in rarer medium. Okay, we know that it is wrong. And this model wrongly predicted that velocity of the light travels faster in denser medium. Now we know that it's wrong. And apart from this, so much failures or wrong. Newton's theory prominent has get what the right word for the 200 years. Okay, it is followed for almost 200 years, and it has failed to explain this much uh, causes like interference, diffraction, and polarization. It has failed to explain this much phenomena and is wrongly predicted the speed of light, but still it is prominated for almost 2 centuries. And when it is in 1800, in 1805, in 1805, 18th centuries, there was a Foucault, Facault. There was Foucault. Okay, he has done a what? He has done experiment. Has done a experiment. He has done a experiment. He has done a experiment, and he showed with 100% accuracy that velocity of air, of light velocity in air is greater than the velocity of light in water. He proved that by the experiment, and at that point this theory, removed, and another theory came in the light. That was Huygens principle, Huygens theory. Then this theory came into light, Huygens theory, and a very interesting thing is that this theory was given in 1678. After the 3 years, the Newton's gave his theory. And the theory, after 3 years, Huygens gave his theory. But Huygens did not get recognition because Newton's name was that much heavy and has that much effect in the scientific field that this theory did not get recognition. And after Foucault successfully proved that this Newton's corpuscular theory is wrong in 1805, then after that much time Huygens theory gets its recognition. This much time. Okay, so let's do question time. Question time. Okay, so this is actually PMT question, a very easy question on that. So the question is, by the corpuscular theory of light, the phenomena which can be explained is refraction, A, refraction, B, interference, C, diffraction, or D, polarization. A, refraction, B, interference, and C, diffraction, or D, polarization. Which phenomena of the light can be explained by Newton's theory of corpuscular? Which? And the right answer is refraction. Refraction can be proved by Newton's corpuscular theory. Interference, no. Diffraction, no. Polarization, no. Another question. According to corpuscular theory of light, the different colors of light is due to. According to corpuscular theory of light, the different colors of light is due to different electromagnetic waves, different force of attraction among the corpuscles, different sizes of the corpuscles, or D, none of the above. I am repeating the question again. According to corpuscular theory of light, the different colors of light is due to different electromagnetic wave, B, different forces of attraction among the corpuscles, C, different sizes, or D, none of the above. The right answer is C, different sizes of the corpuscles. C, yes, you are right. Let's continue, and if you haven't subscribed our channel, in the YouTube, if you haven't subscribed our channel in the YouTube, make sure that you are subscribed. Make sure you are subscribed and press the bell notification icon to get the updates daily. After this, which scientist came? Huygens came. Huygens came. He said, light is a mechanical wave. He said, light is what? Light is a mechanical wave. Light is a mechanical wave, and it requires a medium to travel. Okay. He was a French scientist. And French or Dutch? I have to search it. Is he French or he is Dutch? So Huygens wave theory, which was given in 1678, has given its what? Attention. Has given its attention. So it says that light is what? Light is a mechanical wave. Light is a mechanical wave. So some scientists ask, Huygens, please do answer. Please do answer. Let's say this is Earth. Let's say this is Earth. This is Earth. This is Earth. And this is Sun. This is Sun. This is Sun. Sun is a light source. We all know that Sun is a light source. Sun is a light source. Now do tell me, Huygens, how the that wave, the light wave, can come from the Sun to Earth, and there is no medium between. There is no medium between Earth and Sun. There is no medium between Earth and Sun, and you are saying that light is a mechanical wave. You are saying that light is a mechanical wave. So Huygens answered. What Huygens answered? Huygens answered, listen my buddy. We all know that velocity of the particle traveling the medium is given by this. E upon rho, where E is elasticity and rho is the density of the medium. E is the elasticity of the medium and rho is the density of the medium. You know that? He said that there is ether. There is ether between Earth and Sun. It is everywhere. Whole universe is filled with ether. There is no vacuum. There is no vacuum, but my dear scientists, there is ether. There is ether, and ether is very dilute. Ether is very dilute, means rho very small. Rho is very small, and it is highly elastic. This E, elasticity, E values very high, highly elastic, and density very low. If you make the E value very high and rho value very less, then you will get the velocity of the light in the ether medium. And we say like, okay, that is correct too. So ether concept then came. Ether concept then came. It is interesting that how the ether concept came in the scientific society. What he said, that velocity is equal to, in elastic medium is E by rho. So he said ether is highly elastic and very, very small in what? Very, very small in density. So we will get very high what? Velocity of the speed of light. So that's how we get the ether concept. This is the first thing he said. Light is a mechanical wave. After this, It explained rectilinear propagation of light. It explained reflection. It explained refraction. How he did it, we will explain it. It explained interference, that Newton's corpuscular theory failed to explain. It explained diffraction. It failed to explain diffraction. Sorry, it explained diffraction, but it failed to explain polarization. It failed to explain photoelectric effect. It failed to explain polarization. It failed to explain photoelectric effect, and how it is not explaining these things, we will also see it. So interference, diffraction, polarization is very important, and we will do all these things in our upcoming lectures. Interference, polarization, and diffraction. So first Huygens principle gave so this guy Huygens gave some principle, and he says that you have to take it, that if you follow this principle, you will get the what Newton nature of the light. So he says that what is wave. He said that that source that source create what create wavefront create wavefront okay, which travels. You can just imagine like throwing a stone in a pond, and you will see ripples. You will see ripples like this. So if you imagine this circle, in this circle, this locus we will have, all the particles are here is vibrating in the same phase, and he has given the equation like this: y is equal to a sine omega t plus kx. A is the amplitude, and this omega t plus kx, you can say it is phase. For now, let's say it is phase. It is the phase of the wave. Y is the displacement of wave. And displacement of wave. If you have any doubts, you can ask me. If you have any doubts, you can just ask me. I will answer your all the queries. If you have any doubts, you can just ask me. Okay, I am here to answer all your queries. And x is what? Position of the particle. Let's write it here. Let's do right here. X is position of the particle. In medium. Y and acceleration. Okay, y and acceleration. Omega is what? Your angular frequency. T is time. K is wave number. The important thing is y, and this is phase, and this phase. Do we get it? Okay. Any doubts, my dear friends? So he said that wave is a mechanical wave, and there is a wavefront, and in this wavefront, every particle will vibrate in the same phase. Okay, in the same phase. This is circular wavefront. This is called what? This is circular wavefront that will happen in what? In the surface. Ripples on the water surface is the example of circular wavefront. Okay. Okay. So medium travels like this. Medium travels like this. Medium travel like this. It is moving in a what? In moving direction straight. And if we create a locus, in this locus all the particles are vibrating in the same phase, means they are in the same phase. Another thing is said. Let's say this is our wavefront. This is our wavefront. This is our wavefront. So this is wavefront. If we take a small area and make a normal, or take a perpendicular. So in this direction, wavefront normal will give the direction of propagation of wave. Direction of propagation of wave. Direction of propagation of wave. What I'm saying, let's say this is our circular wavefront in water ripple. So if we make a normal here, so this will give what? This will give us the direction of propagation of what? Wave. This will give us the direction of propagation of wave. So let's say this is our point source medium. So these are what? These are the propagation direction. Propagation direction, and this is the wavefront. This is the wavefront. For point source, for the point source, we have spherical wavefront. For the point source, we will have what? Spherical wavefront. If you have any doubts, you can just ask me. Okay. For the spherical, we have, for the point source, we will have spherical wavefront. For the point source, we will have spherical wavefronts. And let's say if the source is at the infinity, then what we will have? We will have planar wavefronts. Okay, these are the rays. Is that coming? And if we make wavefront, the wavefront will be like this. So in this wavefront, all the particles will have what? Same phase. All the particles will have same phase. For the planar. And the direction propagation, if this is medium, this is our planar wavefront. Okay. And make a what? Make a normal. So this normal will give what? Direction of propagation. Direction of propagation is always going to be perpendicular to the wavefront. Let's say for the line source, this is the line source. Its wave will move like this, and this is going to be perpendicular to the wavefront. So make sure that you know the direction of the wave propagation is always going to be the perpendicular to the wavefront. The direction of wave propagation is always going to be the perpendicular to the wavefront. Okay. Let's revise again. Point source will give spherical wavefront. Parallel rays will give planar wavefront. Point source will give spherical wavefront. Parallel rays will give planar wavefronts. And line source will give cylindrical wavefront. And the line source will give cylindrical wavefront. Spherical, cylindrical, and planar. Okay. Now what he said in another thing. Now he said that each point on the wavefront, like says this is our point source. And these are the mechanical wave that is traveling. So this is our wavefront. So here, all the particles are vibrating in what? Let's say this is our point P1, 1, 2 and 3. 1, 2, 3. and they are all vibrating in what? They are all vibrating in the same phase. And now it is saying, so these particles will act as a what? Will act as a new source. Okay, will act will act will act as a source of disturbance. Source of disturbance. Okay, they will act like a source of disturbance. Now mechanical wave is traveling, and now let's say there is it is travel to here, travel till here, and there are particles 1 2 3, they are in same space, same phase. And now these particles in this wave front, this particle will act like a new source, will act like a new source. And from this from these particles, a secondary wavelet, secondary wavefront will emerge. Secondary wavefront will emerge. This secondary wavefront will emerge. This are called secondary wavelets. For primary source, they are called primary wavefronts. And from the secondary source, we will get what? Secondary wavelets. We will get secondary wavelets. Are we clear? Are we clear? This are not called secondary wavelets. These are not secondary. These are the particles that are vibrating in the same phase, are acting as the secondary sources. They are acting as secondary sources and giving rise to the secondary wavelets. Giving rise to the secondary wavelets. Okay, and these wavelets are spherical in shape because they are going to act like as what? They are going to act like a point source. They are going to act like a point source. So they will create what? Secondary, they will create spherical wavefront. They will create spherical wavefronts. So these wavelets are going to be spherical in shape, and they are going to spread in all directions. What will sphere do? Spherical wavefront are like this. They are going to spread in all directions. So they are also going to spread in all directions. Okay, कोई भेदभाव नहीं है, ये सब जगह फैलेंगे. So they will act like a new source, the particles in the primary wavefront, and will create secondary wavefront, secondary wavelets. Okay, and if we do one thing, let's say this is our primary this is our primary wavefront. Okay, primary wavefront, and we have made secondary wavelets like this, secondary and this is our secondary wavelets from this, from here, from this particles, not like this. Let's make it like this. From here, 1 2 3 and 4, it is created 1, it is created 2, and from is 3, and from 4. Sorry for my drawing, but this all are equal. Okay, and if we make a tangent, normal, and this will be like this, will be like this. So we will get this. And if we do connect them, like this, if we do connect them, we will get our secondary wavefront. We will get our secondary wavefront. We will get our secondary wavefront. We will get our secondary wavefront, or you can say we will get our new wavefront. Okay, my dear friends. So this is primary, and this is our secondary, the new we got. After this, let's study the behavior of planar wavefront on reflection diffraction. Behavior of plane wavefront on reflection and refraction. Okay, behavior. Let's talk about behavior. Let's talk about the behavior here. If there is let's say there is a wave coming, there is a wave coming like this, there's a wave coming like this. Planar wave, planar wave will have what? Planar wave will have, sorry, parallel rays will have planar wave front. This will have planar wave front. This will have planar wave front. Okay, after the refraction, what will happen? This will go like this, this will go like this, like this, like this. So in prism, by refraction through prism, there is no change in wavefront. It changes its direction, but there is no change in wavefront. There is no change in wavefront. It's changing direction, like coming like this, and now it is going like this. After the refraction through prism, it is coming like this, and after refraction it is going like this. Okay, this is from the prism. This is from the prism. Now in another example, let's see by the convex lens. By the convex lens. Convex lens is like this. Convex lens is like this. Now it is interesting. Now this thing is interesting. Let's say there is a planar parallel rays are coming. Parallel rays are coming, and initially the wavefront is like this. Initially wavefront is like this. Initially wavefront is like this. After what will happen? After what will happen? They will meet at the focus. They will meet at the focus. Like here. Now they will meet at the focus, and now this planar wavefront, will become a spherical wavefront. Now this planar wavefront will get converted into what? Spherical wavefront. Planar wavefront has converted into what? Spherical wavefront. Planar into what? Spherical. Planar wavefront into spherical wavefront. After this we have concave lens. This is not concave. This is concave. Reflection of plane wavefront by the concave lens. By the concave lens. By the concave lens. Now let's see. Parallel rays are coming. Parallel rays are coming. Parallel rays means what? Parallel rays means planar wavefront. This means planar wavefront. Planar wavefront. Its focus will become here. After this, it will go like this. They will go like this. And we can imagine if we do the opposite, it will be like this. Okay, focus. They will meet. We will see seeing that it is forming where? It is forming at the here focus for the concave, and we will get the wavefront like this. This and this will be the new wavefront. So they are what? They are also converted into the spherical wavefronts. This is planar wavefront. Initially it was planar wavefront, and after refraction, this is refraction. After refraction through the concave lens, it is converted into what? It is converted into the spherical wavefronts. It is converted into the spherical wavefront. If you have any doubt in this thing, you can just ask me. You can just ask me. And let's do a question. Let's do a question. Question is what? By Huygens wave theory of light. By Huygens wave theory of light, we cannot explain the phenomena of. What we can't explain by the Huygens wave theory? What is the thing that we can't explain? Interference, diffraction, photoelectric effect, or the polarization. What we can't explain, what we can't explain by the Huygens wave theory. What we can't explain by the Huygens wave theory. Do tell me. The correct answer is C. Photoelectric effect. The correct answer is C. Photoelectric effect. Okay, my dear friends. Okay. Now, what our course looks like? What our course looks like? In the crash course that we are doing, we have 90 plus concentrated and concise classes on the NEET. Okay, nothing extra. Exams are coming, so concise and concentrated classes on the NEET. And you can access from anywhere, from the Android, from the iOS, from the laptop. You just need what? You just need internet, and if you have internet, you can access from us from any platform. You can access us from any platform. Syllabus has made from the NEET experts, so you don't have to, like what I'm doing. Just study what they are telling you, and you will okay, pass the exam with the flying colors. And we are doing this thing by the flipped classroom method. First time we are introducing that in India. We are first time introducing that in India. So this thing is very very famous in Russia, in Ukraine, and European side. Flipped classroom method. So this is the first time that something new and unique is getting introduced in India. And we have doubt solving practice for you, and that is necessary, and that is life. Okay, we have faculties, we have mentors, we have SMEs sitting in the chats. So what do you have to do? You just have to send us the photo or the thing that you want us to solve, and the doubts you have, just send us to us, and they will clear all your doubt, all your queries there. Okay, itself. Okay, you don't have to go anywhere. They will clear your doubts on the chats itself, and you if you want to call them and want to ask by them, or you can also do that. It's on you, and what is good for you. After this is how is our class looks like. Our class looks like theory. First we do theory and previous year questions, and do that in so much detail. Theory we do first we do theory, and we understand and let you learn that all what is needed. Then we will provide you study material, and still if you have some doubts left, there are webinars that you can take and solve your doubts and clears. And also we have homework, and also we also do check them. So homework checking, if you do them very good, then we will say very good, and if you do them wrong, and if you stop doing them, so there are mentors, there are our faculties that will call you and ask you that why aren't you doing those things. So what you can do, you can select a subscription plan. So we have 3 types of plans here for you. First, light, smart, proficient. On all those 3 you will get live classes that we will do daily, and we get structures course and PDF. The material, the study material, that is very very important. You will also get study material. You will also have a chance to do the live test. Okay, so you will get, a hobby at how to sit on the exam. So live tests are important in that perspective. If you have the hobby of sitting in the paper, and how are you going to sit, how are you going to tackle, so that thing will automatically create by giving the live test thing. And you will also get physical notes. You will also get physical note. But if you get smart, you get three things extra. You will get one-to-one mentorship. You will get one-to-one mentorship. What is one-to-one mentorship? What is one-to-one mentorship? Imagine that you want to reach here. You want to reach aims. You want to reach aims, and you are here, and there is some specific path. There is path that has to travel to go to here. Okay, there are lots of ways. One, two, and third is like this. This is going to like this, and third is like this. So what mentor does, mentor show you the shortest and the best way that you can reach to your aim. And we have live doubt solving. Actually, I have already done already explained that what is live doubt solving. That is very, very important for you if you are preparing for the exam. Live doubt solving, that is very, very important. Okay, if you have any doubt, you don't have to have some time, who will solve my doubts. You just have to send your doubt in the group, the groups we have, and there they will solve your doubts at the very spot. And there are mock tests regularly. If you want to give mock test, and you want to see that how much water you are in, that what you have to do, what you have to do not. And this is like, what is mock test? What mock test do? Mock test do the reality test. Mock test do what? Reality test. It tests you that in which topics you are good, in which topics you are bad, in which topics you have to be more concentrated, in which topics you can give a little bit of less time. This is what reality test does. This is what reality test does. This is what reality test does. And we have another proficient course, in which if you lost some lost some courage, and lost some motivation. So this is like the motivation. So we will give you motivation in a regular basis. So that is proficient. So light, smart, proficient. We have three plans specifically for you. And my dear friends, what we have, we currently have running a very discount. We are currently running a discount, in which you can get the plan. You can get the plan of 3,000 rupees, 3,200 rupees plan, 3,200 rupees plan in just 299 rupees. In just 299 rupees means you will be saving 3,000 rupees. You will be saving 3,000 rupees if you choose this plan. If you choose the special, the promo code is NEET PHY 30. NEET PHY 30. If you apply this promo code, this 30 mean that you will get 3,000 rupees discount. So you don't have to pay 3,299 rupees. You only have to pay 299 rupees. Okay. And for some, this amount is a big amount, and you can do many things with 3,000 rupees. You can buy extra books, you can buy a study table, you can buy something more, you can buy in the 3,000 the whatever you want. You can save 3,000 rupees if you apply the promo code NEETPHY30. So we have two groups in Telegram. We have two groups in Telegram. First is our, where you get the notifications, where you get the announcements, where you get giveaways, where you give. You just have to follow and scan this thing. Okay, this QR code you have to scan. And if you want to, and this is our chat group, this is our chat group in Telegram. In that group there is me, there is Vishwajit sir, there is Patakshar. We will do quizzes. Okay, provide you material, provide you guidance, provide you everything that you want. So this is a two group that you can join in the Telegram. If you do follow us on the Telegram, there is a many chances that you can get heavy discounts and giveaways. So it's on you. So see you soon or tomorrow in our next lectures. Till then, take care. Goodbye.